think we'll get the show on the road here. People are still joining, but we have just the startup stuff to go through here. So I'll start just by on the Kiko chat page here, where you've probably all been. So we have the vocabularies, our landing page for the session, and the attendance list is here. So please sign in and let us so we know who's been here and about the attendance. I've got a Jamboard set up. There's a link here. And the idea here is this gives us a place where if, in the course of the presentations, you have any comments, thoughts, questions, anything like that, please throw them on the Jamboard. And we'll come back to that during the discussion period at the end of the presentation. There's links to the presentation slides, or most of them, also on the Kiko chat page here. And we've got a series of presentations here that'll all be fairly short, looking at a variety of different lithology vocabularies. This session was sort of instigated by Kirsten and Leslie nudging me that we needed to do something like this. It's a problem I've been working on for quite a while, and lots of other people here have as well. And so we'll start out with Kirsten and Leslie talking briefly about their interest and experience with using lithology vocabularies in practice, and then followed by a series of presentations. I'll talk about some of the vocabularies I've worked on and been involved with. And then we'll hear from Julian and Ralph about the MnDOT rock vocabulary. And if you are not familiar with MnDOT, this will be very good. It's an incredibly useful resource on the web. Tim McCormick will talk about the BGS lithology vocabularies, which are probably the most authoritative ones that are out there, I think. Vance Kelly will talk about recent work in the Geologic Survey of Queensland, developing vocabularies for their use there. And the use cases they're looking at and decisions they made about what they would use. And then we'll follow that up with the discussion period. There should be some time left at the end. And so without further ado, let's see, I guess, Kirsten, why don't you go first? And then Leslie?
No, I think Leslie should go first because she has sort of that higher level picture.
Right, yeah. Okay, Leslie, over to you. Okay, got your screen?
Yeah, just got unmute.
We hear you.
Okay, so this is me going really high level. Steve asked me to talk about experience with and interest in lithology vocabs. So yeah, as Steve says, quite a few of us have been working on this for a long time. And I regard myself as a senior citizen or old fart. And in the late 1980s, I helped build GA databases using relational database technology. I think it's important for you younger people to realize that storage was $1 million per gigabyte and efficiency was key. Controlled vocabularies were critical to efficient storage. But I also tell you that storage was so bad that we couldn't even hold a whole word. Every one of our vocabularies was reduced to a 2 or 3 letter mnemonic. But the advantage of that was it helped keep the data clean, including those geologists who could not spell. And I reckon 90% of GA couldn't spell at the time when we started this. So at the turn of the century, we joined the international, that's Geoscience Australia, GeoSciML project, worked as an international community on key vocabularies, including rock types. And so I went in with these detailed vocabularies that had been worked out for detailed geochemical and petrographic databases, but technology beat us. And we just could not do the full word vocabularies, and hence GeoSciML Lite was born. But I will add that I felt that was more designed for map legends. And thinking back over time, because by the way, people, when we started this, we didn't have Excel. So can you younger people imagine life without Excel? And you think back about geological science.
How you doing?
And our means,
just checking in.
Our means of communication was really with the picture. And if you think about it, I often curse William Smith's map in 1815 because it was human readable and it took lots of individual observations and created pictures and lumped everything together. And we lost the power of the individual specimen. My interest, science is changing, and I see Bob's here, and I would have put the reference into Bob's talk, but unfortunately ESIP have blocked Wednesday's sessions. You can't see them on the sched anymore. So, but anyway, I think you'd need to listen to Bob's talk because it showed that with the semantic web, we can now visualize millions of individual words, not create visualizations of interpretations of millions of words. We're now in the era of the power of the word. And so there's a series of revolutions that are happening out there. Revolution 1 was Tim Berners-Lee and the vision of the semantic web in 1994. Clearly we need our vocabs to be 5-star. There's the FAIR principles where our vocabs need to be findable, accessible, interoperable, and reusable. And as the Go Fair community keeps saying, it has to be both human readable and machine actionable. I think Revolution 3 is starting to come where viewers are promoting now that FAIR means fully AI ready. It means that we can take all our data now, we have the computational power to do it, and start to really look for those finite granularities that Bob showed so brilliantly on Wednesday. Technology is now no longer beating us, and storage is as cheap as chips. But I also will say that I do find a reticence amongst those who are trying to move into the semantic web because they're trying to do it on local servers or maybe on Amazon. And some of you know one of my roles is I sit next to Australia's largest supercomputer, which is 17 petaflops. And we feel that to really get the power of the word and build these super graphs, people need to start thinking of moving it onto HPC. And if anyone wants to experiment, please contact me. So in conclusion, what do we need to do? We need to create 5-star, and I emphasize the word international, community agreed lithology, vocabularies, and ontologies. Most of the ones that will be presented in this session to me are 3-star or 4-star. The gold standard that we're after is endorsed. And there's a big gap, particularly in Australia, where the geoscience with surveys, government agencies are developing one lot. In the previous talk, we heard about the research community developing them. And we need to work together and at an international level to actually start to say, yes, this is a high quality vocabulary with definitions that are agreed to, not by the technical people, but the scientific. And above all, they have to be multilingual. And I know IUGS went down this path some time ago with the CGI, where you're not, say, translating Granite in English to Granite in Italian, but you're doing that multilingual based on concepts. So Granite has a set amount of quartz, feldspar, and other minerals. What is that concept, that rock, translated to in Italian, Russian, French, German, you name it. And so that's just my feeling of where we need to head. And let's start to agree on what are the ones we need to endorse and support, because as the previous session said, it takes a lot to develop these strong, robust, viable ontologies. So let's do it together through collaboration and not competition. Thanks.
Thanks, Leslie. It's a great introduction to the framework here. And Kirsten.
Yeah, this was really great. And I feel like I don't have that much to add, just my sort of personal experience. I didn't know anything about vocabularies until I started to to build EarthChem and other databases. And the problem was, so there were a number of geochemical databases at the time that all, tried to describe the lithology of rocks that were analyzed. And whoops, why doesn't it allow me to move? Whoops, that was too far. So this is very long ago, 15 years, as you see. In 2006, there were 3 databases, PETDB, GeoRock, and NavDOT, that tried to come together under the EarthChem name and build a portal to all their databases. And what we realized was that everybody had entered the lithologies of samples that were listed in the databases, just as with the classification that was provided by authors in a publication. And I can tell you that was the worst case scenario, because the lithologies that are used in papers are very local, very specialized. Everybody invents their own modifier to the olivine rich andesitic basalt or something. And so when we actually tried to combine the things, it was a huge effort to map the lithologies to some common vocabulary. And we used the BGS classification at the time as a high level to just say, this is a magmatic rock, it's volcanic, it's something. And obviously we did that in a very, non-professional way on an Excel spreadsheet that continuously got outdated and didn't quite do its job. And I can tell you, I actually looked into my computer today and found the old spreadsheet that we had. And what it says at the top here is need to correct the misspelling, just as Leslie just said about the not being able to spell correctly. But you see, and probably you can't see because it's way too small, but there are so many different names in different spellings that were difficult to map. So in order to get around this, we basically said, okay, if we want users of our EarthChem portal to search for a given rock type, what do we give them? So we had, at the bottom here, we had the opportunity to just use the BGS classification and say, I want, igneous, plutonic, exotic rocks that are called alnoids. People could also just use the vocabularies that were provided by the authors, which were fairly meaningless. And what I should have added another diagram here, was what we realized was that names were also used without a real study behind it that confirmed specific classifications. For example, when you selected here in names assigned by collector, you selected rhyolite, and you would plot it on an Harker diagram. They were all over the place. That it definitely wasn't rhyolites. And so what we did was we created this query that actually calculated the chemistry using a TAS classification, and then we gave those names, which was the safest way. But anyway, it was, and to this day, I think we don't have a good vocabulary that we can use. And we now have, a large desire, opportunities, needs to extend data exchange, to extend synthesis, using many different geoscience databases. One thing is our geochemistry effort, trying to build a global network of geochemical databases, or the interaction of different geoscience databases in EarthCube and other efforts, just doesn't work without a common concept for lithologies and the vocabulary. And we see increasingly the need for interoperability at the granularity of individual specimens. And I think that's, another reason why we really need to look closer at this. We have a growing number of digital sample catalogs and networks, be it iSamples, be it the European DISCO and so on, where we really need to have a consistent naming classification of samples. And the mining of, you know, all that available information in these different catalogs with new ways of doing data science on this. That all really requires us to move forward. And I'm very grateful for Steve that he took Leslie and me beating and organized the session because he really is the expert. And I'm looking forward to some great presentations and discussions. All right.
Thanks, Kirsten.
I'm getting out of this and start
All right,
sharing.
we'll move ahead and I'll jump in now. It should work. Oh, gotta get in there. All right, should be seeing full screen rock type vocabularies. So the why, Kirsten and Leslie have both talked a little bit about why, but really we're interested in the rocks because understanding the Earth is based on understanding the origin of the constituent materials, right? So we want to be able to characterize rock types also for looking at Earth system models, looking at fluxes of material, of different constituents, nutrients, elements between things, and for analysis of surface processes. So we want to categorize kinds of Earth material. But the problem, I think one of the challenges we've faced is that there are different levels of granularity that people are interested in here. And so we've kind of, on the one hand, composition of geologic units, on the other hand, composition of individual samples. But we need standardized vocabularies to support data discovery and data integration. And I think we've overheard about that. So who are the users here? So we've got at one level the research geoscientists and mineral exploration geologists who typically want the most specific kind of rock lithology categorization you can give them because that makes a difference for the kind of work they're doing. For other scientists, maybe biologists, environmental scientists, the more generalized systems of categories are probably more useful. They don't need to know all the details. They just have to broadly understand the composition and character of the rocks that are maybe the substrate for the ecosystem they're looking at. On the other hand, engineers are mostly interested in physical properties. So they're not interested in rock names so much as, what's its fracture strength and things like that. And then for the general public, very general categories are generally sufficient. They don't need to know something's allegolitic trondhjemite. They're fine with diorite, or something like that. So we have these different levels of granularity in terms of the spatial extent of the things we want to describe lithology for, but also the target community that's going to be using the vocabulary. And we have to work in both of these dimensions. So I'll focus mostly on the scale of description. And we have at the hand sample level, so the kind of rock you can hold in your hand. And this is the level of lithology that geochemists for geochronology, for petrography, a hand sample can generally be characterized as a single rock type. Whereas if you start thinking about regional geology and what you see on geologic maps, it's pretty unusual to have map units that are really homogeneous in terms of the lithology. And more detailed maps would tend to be more homogeneous, but regional geology maps generally have really heterogeneous units to deal with. So now jumping into some of the vocabularies that have been developed, I think we've already mentioned the CGI, the Commission for the Management and Application of Geoscience Information, the IGS, in connection with GeoSciMel, developed a vocabulary that's, people call it, it's the simple lithology vocabulary. It has 265 classes and was really developed for hand sample scale description. So the kind of things you can hold in your hand, how would you categorize them? This was developed by an international working group, and I think we have a number of members of the working group here, including Mark Rattenbury and Leslie and other people who worked on developing this. And the idea was to provide a vocabulary for populating geologic unit descriptions in GeoSciMel, which was an information interchange language. So the terms in this vocabulary have definitions. It's got a hierarchical structure. And we tried to be logically consistent about the definitions so that they're unambiguous and there aren't overlaps. That for any given rock sample you have, you could throw it in one, but there's 265 classes for all the kinds of rocks on Earth. So as you can probably imagine, it's fairly high level. A couple of other ones, they're the geologic, for describing lithology of geologic units. There've been a couple of big projects that the USGS has done here in the United States. The GEMS, which is what Geologic Map Model System, it's a relational database design. But one of the fields in this data interchange format or standard geologic map design is a field for a generalized lithology. And there's a vocabulary associated with this called geomaterials that has 101 categories in it. And there's a spread, these are defined in a spreadsheet, and there are terms and definitions. And the idea is these are used for geologic map databases to make it easier to integrate quadrangle scale sort of geologic maps. Another project the USGS did was in the Mineral Resource Division. They have this state geologic map compilation where they, over the course of 5 or 10 years, digitized the state geologic maps for all the states in the US. And in connection with this, they developed a set of generalized lithology terms to characterize the rock types that were in the units. So this is just a text table in a PDF. There's 180 categories, more or less. No definitions, just the words. And so the way they were working was if the words that appeared in a map unit description were the words that appeared in the database. And they didn't try to deal with all the vagaries of how different people use different terms. Another effort in this activity is something I've sort of been working on over the last 5 or 10 years is thinking about, okay, well, if we did want to have a lithology characterization for map units at a regional scale, what would that look like? And so this was a project where I took a bunch of regional geologic maps, the geologic map of the Arctic, geologic map of Brazil, geologic map of North America, geologic map of Europe, geologic map of Russia, looked at the rock types and the descriptions of the map units in those and tried to, from the bottom up, synthesize, okay, what are the different kinds of things that appear in these maps? And came up with a scheme with 84 categories in it that are defined based on assemblages of rock type, but also related to their genesis. And so one of the ideas here was that we want to, for these kind of maps, the lithologic characterization ideally would reflect how things would actually look when you're out there in the field looking at the areas that are mapped in these units. So this is a sort of more continental scale system of lithology. So the pattern here is that, starting from the middle, which is where we're at this hand sample scale, we have rocks, and rocks are composed of, particles that might be, if they're conglomerates, they might be pieces of other rock, or they might be minerals. And geologic units are composed of rocks, so at a local scale. And then more regional scales, we have compilation units whose parts are other geologic units. So when we try to characterize these lithologically at the hand sample scale, we can say, well, the hand sample is granite, but at a map scale, it's likely it's going to have multiple constituents. It'd be granite, diorite, maybe. And then thinking about it in terms of a larger scale, we just say they're granitic rocks, massive granitic rocks, as opposed to foliated granitic rocks, which would be which would look different when you're out there seeing them in the earth. So just a quick flash on what some of these, the kinds of things. So these are the volcanic rock terms that are in these different vocabularies. And, the CGI vocabulary doesn't actually have a volcanic rock. They're called fine-grained igneous rocks. And the logic there is that when you're holding the rock in your hand, a lot of times you can't tell if it's hypabyssal or volcanic or what. It's just a fine-grained igneous rock. The State Geologic Map compilation has a series of terms which are largely reflecting what you see in the IGS vocabularies, much like the CGI simple lithology. The geomaterials and GEMS start to aggregate things. So there's felsic composition and pyroclastic. So now we're seeing composition and genesis. And then the lithotectonic scheme gets even more generalized in terms of the kind of assemblages you're dealing with. So larger scale assemblages that would appear in units at a kilometer to 100 kilometer kind of scale. So in summary, then, these vocabularies, in order to support querying in an information system, it's nice to have a hierarchical scheme so that you can search for granitic rock at one level, but you could also search for something like diorite or more specific kind of rock, and have your system be able to navigate the transitive closure of some of these kinds of terms. But you also need text definitions so people can be sure they're actually looking for what they think they're looking for. If you're trying to support analysis, it's good to have structured descriptions associated with the term. So there's actually some properties associated with these terms, things like what minerals are in it, what grain size, or how consolidated are there. Maybe even something about density and magnetic susceptibility and other physical properties that you need for doing modeling. And then finally, for supporting map integration at a large scale, you don't want a scheme that has hundreds of units in it, because you can't really portray that on a map. You don't have enough colors to make a useful map. So you need a limited number of units so that you can actually do some useful cartography for presenting information on a map. And so that's just a quick flash on some thoughts about lithology vocabularies. And I will stop sharing now, and we can move on to our next speaker, talking about some other more specific vocabularies. I think, Julian, you're next, I believe.
All right. Let me just unmute myself. I think I'm unmuted now.
We can hear you.
Good, good, good. Okay, right, let me share the screen. You'll be pleased to know I don't have any slides at all. I'm just going to go straight into some tabs on Google Chrome, which I've set up. Right, so, okay, hopefully you can see that now. And okay, so I want to give you a 30 second. You can see everything?
We're good.
Good. Okay, so I'll give you a 30-second introduction to mndotorg for those who haven't seen it. MnDOT started as a private database that I built, started in 1993 to record minerals and their occurrences worldwide. In October 2000, I launched it as a website, as an early community-led database project, and it has been building up and growing ever since then. So you can see some of the statistics that we have here with essentially 1.3 million occurrence records for minerals listed around the world. So essentially our primary aim was to record mineral occurrences at localities. Now, as we start building this up, and we noticed that there's a lot of gaps in the records, because often people were recording the interesting minerals in a locality and not the rock forming minerals, for example. So following on a lot from the work that Bob Hazen and his team were doing with the mineral evolution database and the mineral ecologies, we noticed that these gaps, we could fill a lot of them in if we understood more about the lithology of the localities, and we looked at the rock types listed. So for several years, I started asking people, hey, I need a database of rock types to put into MnDOT. And I soon realized that no one really had anything in a format that we could use. So I finally gave up and said, well, I guess I'll have to do it myself. It can't be that hard, can it? So I started with of course, the BGS rock classification scheme. And one of the problems with this, from our point of view, is that we are building up essentially a hierarchical list of rock names. We need to be able to have, a list of, these are the rock names, this is how they relate in a hierarchy. And when you actually look at the listings, if you actually look at these, the documents from BGS, essentially it's a lot of tables. And if the rock contains this, go to look at table set, this particular table, or go and look in this triangle if it contains that. And to convert that into a hierarchical table of rock types turns out to be quite tricky. So the trick that I discovered fairly early on for this was that it made a lot more sense if you, rather than having a simple hierarchy where everything fits in with a parent level, where rocks can have, in our case, 2 parent levels. So it can be placed in 2 different places. Now, in the very basic sense, this works great for volcaniclastic rocks, which can be listed either as sedimentary or igneous, depending on how you want to look at them. So those sort of issues are covered by us with this very simple hack, really, of having 2 parent levels for rocks. Then also I brought in the information from the IUGS as well, obviously books like this, which also provided a lot of information on the historical names. Now, for us, this is really important because we're not looking in general at hand samples and trying to classify something anew. What we're looking at is essentially pre-existing documentation. So reports of a locality in the journals, in the literature. And some of these may be 100+ years old, and using names which are now would be regarded as obsolete. So it was really important for us that not only we record these obsolete names, but try as best as we could to integrate those into this hierarchy, obviously flagging them in such to say these are no longer regarded as official names, but being able to still get useful information out of it. And in many cases, these historical names have some very specific meaning, which from a mineralogical point of view is actually very important to us because it defines a very specific combination of minerals. So going back to what we did, our top level parent is of course just rock. So we have a little description, and then we have starting with the subdivisions. And so we can go down to igneous rock, normal crystalline igneous rock, and so on. Now, a lot of this is based on both the IUGS and the BGS documentation. The one thing which the BGS did, which I thought was extremely important, was the hyphenating of root names. So, we can tell that quartz alkali feldspar syenite is a root name, and it's not just a syenite that contains quartz, alkali, and feldspar, quartz and alkali feldspar. So that's the starting of our hierarchical system. And of course, problem we have is that you always start with igneous rocks, and then suddenly you think, okay, you've got a system that's starting to work. And then you start looking at metamorphic rocks and you go, oh. Metamorphic rocks are a very complicated thing to deal with because there are multiple ways to describe the same thing, depending on whether you're describing what it is or what it was. And those are all valid and depending on your context. And bearing in mind, what we've been trying to do is trying to aggregate information which is in the historical record. We can't ensure that people use one or the other. People are going to be using both, and we have to be able to record both. And it's impossible for us to be able to completely match things up because there is no way of easily combining these things together. So essentially, with the metamorphic rocks, which I will scroll down here and we'll have a look at somewhere. Essentially, we have parallel levels of parallel hierarchies within the hierarchy for the meta rocks. So these are what things were versus things based on either the composition or the of the structure of the rock. So this is inevitably going to be messy. The most important thing that we can do is to be able to try to record what the names were used for. So if a name is being mentioned within the literature, whether it is a name that is a currently accepted name, or whether it is a name for something that is an archaic varietal name, we have, as best we can, a description of what it is. And then obviously we can use that information going forward. So this actually ended up working out fairly well, and we managed to build up quite an extensive list. I even got so into all of this, I ended up going off and doing all the meteorite types as well at the same time. So we have all of the meteorite definitions as well. So yeah, if I just quickly look at granite as an example of one of our sort of root levels. Well, it's actually more than a root level. We have the classification here. We've got our classic QAPF diagram to show what it is. And then obviously we have the subdivisions. So here we have in bold, here we have root names. And then we have names which are either, the names which are appearing at the moment are names which we have added as and when we have found them within the literature and we've needed to add them. So this is not by any means an exhaustive list because this is going to grow. One of the things that we are looking at, and one of the objectives in the future, is to try and simplify things a little bit by having effectively the modifiers for whether it is a lithium, mica, granite, essentially just becomes a modifier of granite. Now, we don't have a good way within our system at the moment to handle that, but it's certainly something that we know is necessary moving this forward and moving forward to a system that actually can become useful to people other than us. So that's a key objective moving forward, is being able to build a system in for managing that. And as you can see here, we have different varietal names and local names. And it all tries to be fitted in as best as it can. And clearly, we have a lot of work to do still on this. And obviously, right now we've got to the point where people are interested in using this list for projects beyond MnDOT, which for us is very exciting, but at the same time also quite daunting, because this was designed essentially for internal use. And now we feel a greater responsibility in order to actually do this properly, clean this up and build it in a way that is going to be useful for everyone. And obviously, our interest primarily is mineralogy. So we would certainly bow down to experts from in petrology who know a lot more about the best way to organize things than we do. We would certainly value any input in adapting and moving this forward, particularly in combining it with other systems that are out there now. So yeah, I think that's probably all I need to say right at the moment. Obviously, I'm happy to take questions as and when, and if necessary, show some more things if anyone wants to see anything in particular.
All right, thanks, Julian. I mean, MnDOT is a fabulous resource, and I think a lot of us are really interested in seeing how we could make the information that's gathered there more accessible, through APIs and things like that. And I think there's some work going on in that direction.
Yeah, can I'll just update on this. We've just heard that our proposal for funding for building a public API server for MnDOT, which was put forward as a funding proposal through the EarthCube system, has been recommended for approval. So we're hopefully that will all go through, and we'll be able to start on that in October. So hopefully by the end of this year or the beginning of next year, we will have a properly working API server, at least in a basic sense, that will be able to be used by anyone who wants to use the MnDOT information, whether it's just for the taxonomies that we're working on, or to get access to the richer data that we've been collecting over the last 20 plus years.
Wow, that's great news. Denise, were you raising your hand there or just doing dancing or something? All right.
Bridget has appeared. So I'm just playing with her.
Okay, well, moving right along, our next speaker is Tim McCormick, who will be telling us about the BGS lithology vocabulary, which Julian mentioned, and I think let's move in. Can you take over, Tim? Thanks.
Okay, hi. Hopefully you are looking at a title slide from me. Yeah, hi, my name is Tim McCormick. I run the geoscience vocabularies at British Geological Survey. And I'd thank Kirsten for giving me an opportunity to talk in this session. Now, is that going to advance to the next slide?
Not yet, but there was a slight delay, wasn't? Let's see. It has not advanced.
No, it's not advancing, is it? Why is that not happening?
Use the arrow in the lower left.
There we go.
Oh, are you seeing the second slide? That's great, because I'm not.
Yes, we can see it now.
Okay. So hopefully you are looking at a diagram that I'm going to apologize for because it's got lots of very small typing on it. This was drawn by a colleague of mine, another Tim Kearsey, and he wanted to understand the ecosystem of data sets that we have within BGS. And you can see that they're color coded.
It's off again.
Tim, we switched back to your first slide.
Have you?
There, now we got it.
Okay,
yeah, it's not in presenter mode. That might be.
So you can see the color coding of licensed, those that we give away for free, and data sets that we use internally for doing our work and which feed into the products and services that we produce. And up at the top left-hand corner, you can see that there's two key vocabularies. There's the rock classification scheme and the lexicon of named rock units, which is our vocabulary of lithostratigraphy for the British Isles. So I'm going to talk about the rock classification scheme. This isn't working too well at all, is it?
Steve, would it be better if you run the slides? Because you've got a copy of them.
Hold on, yeah. Let me see if I can. Go ahead, Tim. I'll see.
Okay, if I stop my sharing.
Okay. And I'm going to start sharing. We're on slide 3, I believe.
Yeah. This is probably just lack of technical knowledge on my part.
Okay.
So yeah. So the original driver for developing the rock classification scheme back in the 1990s was the move to develop a digital geological map of the UK. So the scheme was published as 4 BGS research reports, which Julian has already shown you some examples of, and these can be freely downloaded off the BGS website. And in 2006, there was an additional part of the scheme was added for naming and classifying unconsolidated deposits, sediments, in a way that was consistent with usage by the British geotechnical industry to be consistent with British Standard 5930, which is what the industry uses. Next slide, please. So the scheme is a descriptive scheme based on attributes like the composition and the grain size, which you can see in hand specimen or in thin section. It's not a genetic scheme apart from, I guess, the basic subdivision into igneous, sedimentary, and metamorphic. The scheme currently has 622 root names. So these are the names of rock and sediment types, which can be assigned if you have sufficient information, which may come from hand specimen or from thin section. And it has 187 approved names, which are the lower resolution terms, the terms higher up in the hierarchy, which can be used as field observations. So in the examples I've shown at the right, in the upper example, we start at rock and sediment, which is the root of the hierarchy. And we pass down through some approved terms, igneous rock and sediment, crystalline igneous rock, and so on, until we come to granite and also monzo granite. And both of those are root terms. And the lower example, similar, start from rock and sediment and going down into limestone and lime packstone. Next slide, please, Steve. In addition to the root and approved terms, there are also a whole load of extra terms which are there just to make our information systems run. In fact, we have these terms with qualifiers. So examples there: biotite granite, sandy limestone, ferruginous sandstone. So we have these terms with identifiers in our vocabulary, really to make our own databases work. And also because the digital geological map of the UK was developed as an Esri GIS, which is really a flat file. As Steve mentioned in his talk earlier on, you wind up having to attribute polygons with identifiers representing mixtures of rocks. So we have these what are called composite terms, granite and diorite, sandstone, siltstone, and limestone. So these are kind of additional things that are not really part of the rock classification scheme. They're in our vocabulary. They can be filtered out in any particular delivery. Next slide, please, Steve. So I've got several slides where I've just taken a very rapid kind of hitchhiker's guide through the rock classification scheme. So igneous rocks and sediments divides into volcaniclastic, the normal crystalline igneous rocks, coarse-grained, medium and fine-grained, and the exotic crystalline rocks, kimberlites, lamproites, lamprophyres, carbonatites, so on. Next slide, please. I'll go through these quite rapidly. They're on a version of this presentation that has been loaded to the landing page for this meeting. The metamorphic rocks, metasedimentary, metavolcaniclastic, meta-igneous, and in each case we can classify them if we know what the protolith is, or based on modal composition, or based on textual attributes. Metamorphic rocks where we don't know what the protolith is. Also other kinds of things, mechanically broken and reconstituted rocks, fault breccias, myelonites, and so on, metasomatic rocks, skarns, grisons, etc. Next slide, please, Steve. Sedimentary rocks, this should all hopefully look fairly familiar. The siliciclastic sediment and sedimentary rocks, rudaceous, arenaceous, and argillaceous. The carbonate sedimentary and sedimentary rocks, lime sediments and limestones, dolomite sediments, dollostones, things like natron and thermonatrite and so on. The phosphate sediments and phosphorites. Next slide, please, Steve. The iron stones and iron sediments, organic rich sediment and sedimentary rock, that's where you'll find peat and coal. Non-carbonate salts, that's a fancy name for anhydrites, essentially. The non-clastic silicious sediments, those are silicious oozes and silicious rocks, diatomite, radiolerite, and so on. The clays, illite clays and kaolinite clays, bauxite and so on down the bottom of the slide there. Next slide, please, Steve. And then superficial deposits, we have a classification, a simple classification of artificial things. BGS does mapping in urban areas after all. So brick, concrete, domestic garden refuse, so on. Residual deposits, biological deposits, the oozes and radiolerite diatomite, which you actually saw on the previous slide, you might remember. They actually appear twice in the classification. And chemical deposits, bargo iron ore, tufa, and so on. Next slide, please. And I think finally, yeah, so these are terms, this is the extra part added in 2006. These are descriptions of unconsolidated sediments as used by geotechnical engineers in Britain. They construct these text strings, bouldery peat, clayey boulders, gravelly clay silt, and that kind of thing. So, yeah, thank you. The best way currently to see the classification and the hierarchy, it's now being made available on data.bgs.ac.uk as a SCOS vocabulary. And this is thanks to my colleague Rachel Heaven and her team, who has done the SCOS translation and constructed this web application that displays several of our vocabularies. One of which there is the earth material class, which is where the rock classification scheme lives. Can I have the next slide, please, Steve? So I've picked out one entry. Obviously, I picked a nice, neat one that would fit nicely onto a slide. I went for bituminous coal for no particular reason. But you can see we've got a name, we've got the notation. That is the identifier that we use in our databases. And there's a definition. I have recently written these definitions for all of the root and approved terms. So not for all of those terms with qualifiers or for all of those composite terms, the terms representing mixtures, but the root and approved terms should all have a definition. And the definitions, you'll notice, all refer back to those rock classification scheme reports. And for each entry, we can see what the broader term is, and we can see the narrower terms that exist within it as well. Next slide, please, Steve. So, so what I think is good about this scheme, it's based on a single coherent series of sources, those rock classification scheme reports. The scheme, I think, is relatively simple. That's easy for me to say because I understand it. It's by and large a single parentage scheme. Most of the entries only appear once in it. They do not usually have multiple parents like the CGI simple lithology scheme has. It includes both rocks and sediments. And it's the scheme that we've used for more than 20 years within the British Geological Survey in a variety of settings. We've used it for mapping both in the UK and in other countries in a variety of terrains and geological settings. We use it for creating our 3D models. It's used in engineering geology, importantly, and it's used in all of those various other usages as well that I've mentioned. What needs work? My colleague Tim Kearsey is proposing to do a modification of the sedimentary part of the rock classification scheme. There are some parts of it that are controversial within BGS. Particularly the level at which sediments are separated from sedimentary rock, which happens at quite a low level in the hierarchy at the moment. Many of our geologists would like that at a higher level. There's sundry tidying up activities to be done. I would like to add alternative names, regional names to the scheme, and this would be very helpful for me in work that I do. I do a lot of work with geological surveys in developing countries, particularly in Africa. And I think that would make the scheme more useful for those purposes. And it does need better search, display and delivery tools. For example, the web app you just saw at data.bgs.ac.uk does need a search form and an API, which it does not yet have. Next slide, please, Steve. I think I just grabbed a couple of pictures of the scheme in use. So this is Geo Index, which is an app we have on the BGS website, which displays some of our spatial data on maps. And this is showing the lithology for the Scottish coal measures around Edinburgh. Next slide, Steve, please. And this is just an image of one of our databases. This is our database of the downhole geology down boreholes for the country. So this is an internal database. This has just over 4 million rows of data in it. And you can see they're highlighted in yellow. Those are our identifiers for the rock types being used in that database. Last slide, please, Steve. So I've just put some links on here. That's got my email address on, and also the addresses of the linked open data website, which you just saw pictures of. And I think I'm going to stop there. Thanks for taking over the slides, Steve. Thanks.
All right. Thank you, Tim. Tim, are there resolvable URIs for the lithology types in the vocabulary?
Yes, there are. I didn't actually show that on the slide where it showed bituminous coal, but yes, there are. Yeah.
Okay, great. Super. All right, moving right along. I think our next speaker is Vance Kelly from Geological Survey of Queensland. And Vince, oops, what the hell is that? Oh, that's from Simon. Thanks, Simon. Vance, are you there?
I am. Can you hear me?
Yes. Can you grab the screen?
Yeah, really threw me off my game, that pop-up. Can't share while someone else is sharing.
Oh, okay. Tim, can you stop sharing? I don't think, oh no, I'm sharing, sorry. My fault.
Oh, you're good. Okay. Let me know when that's working and we'll kick straight along.
All right. We have the red earth again.
The red earth. Yeah, thanks, Steve. Thanks for inviting me to speak today. I'll just let everyone know that this time yesterday, I had the second Pfizer dose, so I might not be as focused as I usually would be. So as my name says on the screen, I'm Vance Kelly and I'm the Principal Data Manager for the Geological Survey of Queensland here in Queensland, Australia. I was once a petroleum geologist, but I'm by no means a rock typing guru. So I think the value of what I'm about to present isn't so much the content, it's how we went about the process and the way that this really enables some collaboration. So I'm really going to speak more on the context of this as a vocabulary in concept rather than as a specific rock type vocabulary. So as with all geological surveys around the world, we deal with data that services industry, academia, interest groups, and the general public. Now, if my screen changes, there we go. So the GSQ lithotype vocabulary is one of a whole library of RDF vocabularies that we use to describe our information. We have an ever-expanding list of other vocabularies, and that includes related topics like mineral species, geological commodities, which is very closely related to rock type, and geological features. We use these vocabularies directly in our internal database, and they standardize inputs with controlled terms. And we also use them in our open data portal, and that creates rich and consistent metadata that facilitates our search and discovery for all our data sets and our reports. Now, since the major source of the data that we get is the resources industry, our data quality relies on enforcing standards externally where we can and enabling consistent and reliable mapping to our terminology where we cannot. Now, the GSQ is not claiming to be an international authority on petrology or rock typing, and we're not establishing our own unique classification scheme here. So unlike some of the other vocabularies that you've heard about, the story of this vocabulary is more about harmonization than it is about definition and classification. So the intent of this presentation is not to discuss content and structure per se, but rather to discuss the harmonization of established classification schemes and the management and upkeep of this vocabulary that can be leveraged for that collaboration between organizations. Now, the development of the GSQ lithology vocabulary was influenced by a few factors. There was the requirement to meet a very broad range of users and needs, the wealth of information that was held within our legacy systems, but with all the flaws and the gaps that you'd expect from a system that was first established in 1988. Getting almost as old as me, but not quite. And to be frank, it was influenced by our own naivety when we embarked upon the process and the order of engagement with all of our data sources. So to give the absolute briefest of histories, first, of course, we cleansed our internal code list, which was expansive and slightly bizarre at times. Then we integrated the logging and mapping standards from a number of Queensland resource industry members. And they are, after all, our primary suppliers and consumers of our information. So it's a very strong use case to service them. We then mapped to the CGI simple lithology, which we found mapped really quite neatly. And then we moved on to more classical, more popular and expansive lists. And that's the things like the IUGS, Igneous classifications, all the information housed in MnDOT, which is enormous and a huge help, and the rock classification scheme that you just heard about from the British Geological Survey. Now, overwhelmingly, we found convergence between all these classification schemes. The similarities really swamped any perceived differences. So the GSQ vocabulary amalgamated and consolidated as much as possible. And in many cases, we used identical nomenclature to the source list to minimize any ambiguity and increase interoperability. The parallels to the other vocabularies are deliberate and largely unavoidable. It's hard to legitimately classify sandstone outside a sedimentary category, although some may try. The exceptions to that convergence were typically edge cases, some of which you've heard about. So things like hyperlocalized specializations of rock types, integration of terms that are outside the true vocabulary scope, such as mineral species, things like alteration styles or rock types that were compounded with interpretational, qualifying, ancillary concepts. Controversial, I know. Now, the GSQ lithotype vocabulary is hosted on our Vocpres page in its human readable form. The link is on screen, and I'll put that at the end of the presentation as well. This service provides a search function, just a simple text box with a search for specific terms, and a collapsible tree-style view, quite similar to MnDOT, to browse and explore the vocabulary. And I can bring this up later if there should be any questions. Now, the vocabulary is in a web-resolvable RDF format using SCOS representation and can be accessed via a Sparkle endpoint. In plain language, that basically means that you can view our stuff on the web and you can use it directly in a lookup in an external system using a database query with filters as needed. Now, luckily for me, you've already heard the origin story of most of the data sources, or at least the big ones, including BGS and MnDOT, that fed the GSQ vocabulary. So the scope should already be largely familiar, and I probably don't really need to go into it. It's not adding a whole lot. However, having talked in the last slide about the divergence from that strict adherence to scope for true rock types or lithology, I should highlight the one deviation that we deliberately included. And that's, controversially for this group, non-rock observations. Now, these came out of integration of the logging and mapping terms used by resource industry proponents in active projects. So these are terms that are proxies that a geologist may use in the field in lieu of a known or an appropriate rock type. So for example, contamination, lost core, voids, veins, sections not recorded. So it was a pragmatic extension to scope to accommodate the use case of real world data capture where life is messy and sometimes we really just don't know. So the result of all this is a list that's just shy of about 3,000 terms, I believe, most of which you'll see in the other rock type vocabularies that you've heard about today. And hopefully you'll notice the similar structures, the terminology, and the deliberate concordance with those lists. Now, in the background, all our vocabularies that populate Vocpres are stored as files in Turtle or TDL format in our GitHub vocabulary repository. Every vocabulary has a single subject scope known as the concept scheme, that scheme, and all the component terms are defined and described with web resolvable URIs, so you can hit them persistently every time, persistent identifiers. They all have preferred labels. They all have definitions. Where appropriate, they'll have broader and narrower terms to enable and describe the hierarchy that we've heard about today as well, so that even a machine can know that a basalt can and must be igneous. And that hierarchy can be as deep or shallow as needed and multi-hierarchical where appropriate. We do have some alternative labels and aliases where we have them, and where there are variations on names or spelling for the same thing. Certainly between British, Australian, and American audiences, anything with aluminium, deliberate, always causes some controversy. We also have any other provenance scope history notes that were available and applicable when we created this. Now, importantly, all the concepts must adhere to the concept scheme's definition and not conflate other systems, at least ideally. Now, we can't get that right every time, but we certainly try to improve. Now, the vocabularies that we've got are dynamic files, and they're subject to continuous improvement as our understanding and knowledge grows over time, and as external parties contribute suggestions and improvements. So anyone with a GitHub account, and they are free, is free to raise issues or suggest revisions through our vocabulary repository. And those suggestions and requests go through a standard discussion process online before we create a development branch with the requested changes and merge it with our master library pending review and approval. There should be a link on screen as well, and I'll have it at the end. It's been talked about a lot today, but I'm going to talk about fair data. And we also have to acknowledge that resource companies, who are the main source of our data, typically have really deeply entrenched data schemas and standard language. And we as the little old GSQ are unlikely to change that overnight. So any transition away from those internal structures is inevitably going to be a really lengthy process. Realistically, we can't force companies ranging from multinational mining corporations all the way down to small explorers working a single prospect to adopt our nomenclature and convert potentially really vast data holdings. But what we can do is ensure that our terms can be confidently and consistently mapped to any internal company terminology. And to enable that, we follow these fair data principles. So to be findable, accessible, interoperable, and reusable. And as a government agency interacting with a wide array of stakeholders, we need to be able to store and represent data in a consistent and understandable way. So we really need to be able to do this regardless of the way it might be captured in the myriad structures and databases that all our stakeholders access and subsequently report to us. So this is a slight aside, but to that end, we have undergone a huge regulation reform for the statutory resource industry reports that we receive here in the state of Queensland. And this now requires digital tabularized submissions of information through a series of submission templates. Now, embedded within those templates, we've created a simple Excel-based dictionary tool that allows operators to map their lithology codes and translate them to our compiled vocabulary. So rather than force really unpalatable or potentially really unrealistic changes, we enable a once-off exercise for each company to map their bespoke list to a common standard, even where that means they might need to generalize their localized and ultra-specific lithologies to something with a bit more global relevance. For us, we receive data that's comparable and compatible to our vocabulary, regardless of who's giving it to us. And for industry, it works in reverse. So if they extract any term from our data, they can translate it back to their terminology. So as I stated at the start, this work is really about consolidating and harmonizing the information from the organizations who have already put in the time and effort to define and classify rock types, including those who have just spoken before me. So this is really about a first step to look at the work that we've incorporated and to collaborate towards the aspirational goal of a single standard or standards. Now, the best way to do this is really not to listen to me list the inclusions that we've derived from other sources that you can go to, but really to go to our vocabulary page on VocPres and explore the structure yourself. So see the matches to your own lists and classification schemes, identify any differences, let us know what we got right and what we got wrong, because we can change it, it's dynamic. So drop us an email, make a comment through our GitHub on what we can do to improve and better represent those consolidated needs of the whole geoscience community. So please do visit these links on screen and we can continue the discussion. Very, very easy to do. So just thank you for your time. Thanks to Steve, thanks to the Earth Science Information Partners, and I'll pass it back.
All right, thanks very much, Vance. That's great. And the presentation is on the landing page for the session in the ESIP meeting session there, so you can pull that back up and look at it again. So this is really, it's interesting to see these, and sort of strikes me that we kind of have the CGI simple lithology is kind of the highest level hand sample description. And the BGS scheme, if I understand correctly, has largely been the foundation for a lot of what's in MnDOT and also in the GSQ vocabularies. I'm wondering if there's a sort of simple kind of mapping relation we could set up between these for integration, where and then we have these maps, these kind of composite unit, and the BGS scheme has some of these composite units, or actually a lot of them. Tim, one thing I noticed when I was looking at the BGS scheme was that there is you use SCOS broader and narrower to link hand sample kind of lithology with the composite units, whereas it seemed like from a semantic point of view, that would make more sense for those to be part of relations, which I know are not in SCOS, but would be a lot more useful, or let's say precise in terms of the meaning.
I'm sure what you say is right. I am going to plead not me gov. I'm not responsible for the SCOS translation of the vocabulary. I maintain the vocabulary itself. It's my colleague, Rachel Heaven, who I think you know, and her team who have actually done that translation. So yes, if there is a part of relation, I'm sure that is appropriate. Yeah, more appropriate, I think.
All right, so I'm just curious about that one. So where to from here? We have these different vocabularies that have a lot of overlap between them. I guess one of the critical things, it seems to me, is that a lot of people are using the BGS vocabulary as kind of a starting point. And I think with the recent release of the SCOS representations for those, and there are now URIs for the various lithology concepts within that vocabulary, I think. I know in the chats, Simon posted a URI for those, but they're .html kind of URIs. And I'm curious about what the thinking is in terms of what are the identifiers for the lithology concepts in that BGS scheme that we might be able to use to propagate through the other more detailed lithology vocabularies, like what's going on in MnDOT or GSQ. I think GA is also using MnDOT as well. Is there a plan for how this would work with URIs that might be resolvable with different kinds of representations? Let's say RDF Turtle, HTML, maybe CSV, simple text, various things like that. Any thoughts about that?
I mean, really, once it's in any of the RDF formats, it's entirely translatable between them. I think the really important part comes in what must be in every concept, what must be in every concept scheme. And that's where you start getting well outside geology and more into sort of the data side, where you're talking about shackle validations and all of that, to make sure that everything has a definition, that everything has a pref label, that where appropriate, they have exact matches, close matches to potential other matching schemes or intersectory themes. But yeah, it's a difficult discussion because there are so many SCOS properties and OWL properties and all the ontologies that could be leveraged, and deciding what's the core set, I think we should make as minimal as possible to begin with. It's very easy to say everything should have a name and everything should have a definition. But when you start getting into everything else, certainly I've found it becomes a lot more difficult to convince people to put in that work for their first round of contribution.
So Simon, could you elucidate Simon Cox just posted a comment in the chat there. I'm wondering if you could expand on that.
Yeah, I mean, I've been niggling away at this in the chat in the background, and you know, I found your presentation at the beginning, Steve, very useful, because at least when you're looking at different scales, you can think, right, there's the purpose of introducing a classification at different scales implicitly is different. But my big concern here is that it feels like there's a push to have a single classification system, a single lithology classification system, when we've potentially got very different applications in mind. So an economic geology application is a very different application to a geotechnical classification. Geotechnical application, for example, and the facets that you're using to build a name or a classifier for the one purpose are going to be quite different to the others. Now, there may be correlations. You know, granites tend to be hard and therefore good for foundations, but you know, highly weathered granites maybe not so much. And you know, that's the kind of direction I'm going. And you know, of course, the classical classification schemes that we have are based on a kind of geological storytelling. The you know, the process models, particularly when the classic triple of sedimentary, igneous, metamorphic. Okay, igneous, sedimentary, metamorphic, you know, have a very different relationship to applications other than historical geology. So my concern really is, regardless of the technical aspects, which you and Vance were just discussing, is really stepping back a little and say, you know, a classification scheme for what purpose? And yeah, okay.
I think you're exactly right, Simon. There's a tendency to, despite us being geologists who like splitting things, to oversimplify and try to have this one thing. And is it really appropriate? There's a kind of uncomfortable truth that there's a lot of compounding and intersecting vocabularies that we need. So from a geotechnical point of view, like you're alluding to, the geotechnical geologists in the field, they may only have a passing interest, whether it's a granite or a phyllite or a sandstone or whatever. What they really care about are rock properties. So do we leverage hierarchies?
Mechanical properties in particular.
Exactly. So do we accept that there's a level of specificity that just won't be gained by most people, and we kind of live with that within a single hierarchy, and then we say, no, you've also got to use these other 4 vocabularies to describe what you need? Or do we start splitting out into, there's the rock types for economic geology, there's the rock types for geotech, there's the rock types for teaching high school, you know? I mean, that they could be harmonized, but where do we draw the line to make sure that we are separating true concept schemes from each other?
Interesting question. I mean, I know, speaking as a geologist who's done a fair amount of mapping, I know that from the point of view of the people who are making geologic maps, typically we're thinking more in that historical sense that Simon mentioned to begin with. I mean, there's an awful lot of stuff I've mapped as granite that wasn't actually still granite. You know, it was various kinds of hydrothermally altered stuff, or grus, or different things like that, that from an engineering point of view or an exploration point of view are pretty different.
I find it interesting to this idea that, yeah, it's a certain property that you're actually looking for. And it reminds me what I showed earlier was this idea of actually using the rock chemistry in EarthChem to perform the search and says, you know, I want a rock that has a certain composition, a certain range in, you know, given elements and so on. And what you just said was, you know, that has a certain density, or that has a, you know, or mineral content and so on. What are we, and this experience that the classifications were sometimes way off, right? Because is really a name what we need to use, or is it is it actually certain properties that we need to use in order to find what we're looking for?
Yeah, names are just kind of shorthands.
For bundles of properties.
For bundles of properties.
You sometimes just, I mean, I know also, again, from the database point of view, you know, we have a lot of samples where you have isotope ratios, but there is no major element chemistry, so you can't calculate, or you can't allow somebody to search by that. So, you know, then you still go for granite, or you go for basalt in the search. But ultimately, you know, we should be describing every sample that we have with the appropriate properties. Oh, I see Sky.
Sky, yeah, you raised your hand.
Yeah, thanks. No, this has been a fascinating dive, sort of both this session and the previous one, through so many different vocabulary issues and whatnot that are here. But I guess I'm hopeful that we can kind of work our way through this fairly soon and come up with something that's going to work in sort of practical terms for a reference source. You know, you mentioned gems and whatnot earlier. I've been working with one of our projects that's, you know, trying to use that schema for geologic mapping, and they've had to make some modifications and whatnot to it for this Intermountain West project. And, you know, they got excited about some of the stuff that I was talking to them about, you know, incorporating actual identifiers into the geologic mapping process as they were going through it. And they got excited from the perspective of a micro-citation use case where, you know, they wanted to make sure that as they were putting together a geologic map synthesis, you could get all the way back to the individual geologists who had put the original maps together that they were synthesizing to bring together, clear down at a feature level, you know. So we did some work and we incorporated an ORCID lookup system directly into the database design, so that as they're picking names, they're actually assigning ORCIDs to the geologic features that go back to the original citation source from an original map that's being brought together in some way. And so then they also got excited about, well, what are all the other identifiers that we could incorporate into our mapping workflow here, so that, you know, when we're naming things and identifying things in the mapping process, we can be pointing to identifiers. So, you know, that had me poking around at, well, okay, what's the state of all of the vocabularies these days, and what should we actually use, and what could we set up some sort of a, you know, technical connection so that it's synchronizing data into these Esri geodatabases that they're still using to, you know, build geologic maps in. And, you know, that's where I run into, well, shit, which one do I use? I don't know. There's a lot of them out there. What do we pick? What kind of works operationally? What's the source of definition that people have actually agreed upon? You know, what are all of the, you know, properties associated with the names and whatever vocabularies that we can use in some way. And that's when it gets really confusing in terms of how do we actually bring something into an operational state that people are ready to use, that's both technically robust and actually has the appropriate references and everything behind it that people agree upon. So I hope we can figure it out pretty soon, because right now it seems kind of confusing to me.
It seems to me the sort of critical aspect of this is that for these vocabularies, we have a real clear definition of what's the scope of the vocabulary, what's the concept space. So I think most of the lithology vocabularies we've talked about, or a lot of them at least, are sort of scoped to, you know, unaltered primary rocks, you know, granite, sandstone, things like that are pretty straightforward. Whereas if you were really interested in engineering properties, you would have a different concept space. You would have to do with fracture strength and compactability and compressible strength and things like that. That would be in many ways orthogonal to some of these primary lithology concepts. And maybe if you were a biologist, you would be more interested in something like bioavailable potassium potential or something like that as your classifying property. So it's maybe, you know, the way forward is to really kind of think about, okay, when we build these vocabularies, how do we define really what the scope is? And that's kind of, you know, what are the properties we're categorizing things on? And then to address Sky's problem, you'd have to have some way of knowing, I'm interested in the biological aspect of this thing, so I need a vocabulary that's using, you know, these properties, which is really, you know, not typically how geologists are thinking of things when they're out there mapping and classifying rocks. So we have a problem, and it's not an easy one to change. I don't know what to do about that, but
I think scope really is the elephant in the room in all of this. It's unavoidably where we're going to run into the issues, and using the metamorphic and altered rocks as an example, you rarely run into a problem which everyone hates talking about, which is the philosophical problem of what is a thing. Because to me, a siltstone that's been altered by chlorite is a siltstone with chlorite alteration. But at what point does the chlorite alteration actually become part of that thing to the point where we have to say it's a chlorite altered siltstone rather than siltstone with a completely secondary classification over in the alteration column? And thankfully, I'm not a metamorphic geologist and I don't ever want to be, so I'll leave that question to other people to decide. But it's something that really does need to be thought about where you draw that line between what's in and what's out.
Right.
I
just wanted to come back to the other point as well. I mean, we can here all sit and, you know, talk about the vocabularies that we like or how we want to structure it. How do we actually get geologists to use them, right? I mean, again, what I said at the very beginning was we assemble data from the literature, or we have, you know, scientists register their samples in CSAR, or, you know, and they use whatever classification they think is appropriate, right? Can you, I mean, what do you do to science if you try to all squeeze it into a given structure? Is there, so there's, I mean, on the one hand, to me, the development of something that we all can agree on, which obviously takes effort, it takes agreement, it takes the usual, you know, engineering on the technical side and the social side. But then there is the engineering within the community to actually use this and adopt it. So I think that those are two fairly substantial challenges that we still have ahead. And I wonder if anybody has, you know, what should we do next? Is you know, we just don't want to have these sessions every year and ESIP and have another set of presentations about more vocabularies. We need to somehow decide who can take the reins, who can actually lead a community collaboration to build something together. Is IUGS still, is CGI a place to look at?
Mark Rattenbury's in the audience. I was wondering, Mark, if you'd like to say something, because I think it will end up coming back to the IUGS.
Sure.
Not meaning to put you on the spot or anything, but we're running
no, that's all right. No, it's a great conversation we're all having. So CGI is, it got an overarching sort of aim to standardize terminology at a certain level throughout the geosciences, and particularly in the vocabulary space. We simple lithology, that's something we completed quite a long time ago. It has not really been looked at for probably 10 or 15 years in terms of content. And Steve mentioned the lithogenetic vocabulary is an example of one that we are producing. In fact, I've been a bit remiss in getting it published, Steve. Sorry about that, but we're getting there. So we certainly have vocabularies across many different spaces as well, and things like alteration, for example, is one that we've identified as something that needs to be done. So there is the potential for CGI to at least coordinate some of this activity. The ongoing issue is that we're all volunteers in this space, and we've all got day jobs, and getting that momentum going has proved to be quite problematic, particularly once the guts of the driving data models, GSIML, Earth Resource ML, into that work is sort of reaching a kind of a hiatus in some ways. And so the drivers behind our vocabulary development are sort of kind of petered off a little bit. So yeah, when we're looking for that, what's CGI kind of needs that spur to get a bit of momentum going forward.
Right. I see Tim has his hand up, and we're actually over time. So Tim, let's. I would like to hear your comment or question, and we'll probably have to wrap it up then.
Oh yeah, I was just. I think the conversation might have moved on a little bit from where I put my hand up originally. I was just coming back to this point of the purpose of the classification, and we do have, as I mentioned in the BGS scheme, we've got those terms that the engineering drillers use for describing the engineering soils, you know, all the cobbly, gravelly, clay and all that kind of stuff. I also just had a look on our web app and spotted that we've got the class WRC, which is weathered rock, which subdivides into the 5 classes of weathering rock, you know, from slightly weathered rock to completely weathered rock. And that's an engineering geology type classification. So the terminology is there, you know, exactly, you know, whether we want to call that part of the same lithology scheme or whether it's part of a different scheme. Anyway, that was just what I was going to mention.
That requires that systems allow an instance to be classified more than one way, more than one classifier.
Yeah. So you might have a metamorphic grade and a weathering grade and a protolith, or something like that.
It may also be the mapping terms at the larger scale as well. The cardinality may be best to change there, so you can describe it as a rhyolite and whatever else it happens to be. So
we're kind of back to bags of properties here.
Yeah.
So that's,
that could balloon out very quickly in that discussion.
Right. All right. Well, this has been an interesting discussion, and unfortunately, I don't think we have any easy solutions here. But it's been really informative, at least for me. I hope for other people to see what's going on in the different communities, and to look at. One thing that strikes me is from, you know, basically we had the previous session about ontologies. I think in a lot of ways we're dealing with a similar kind of problem here, where really we're not going to define one vocabulary to solve all the problems, but what we need to be thinking about is how we construct online resources that allow mappings between these different views to the extent that they can be mapped, and ways to recognize which vocabulary is appropriate for particular situations. So anyway, I think we should sign off now. Looks like Patty's putting the chairs on the table here. So thanks for hanging on, and I appreciate everybody, especially those that have stayed up very late in Europe and gotten up maybe earlier than usual on the other end of the earth. So this is a great session. Thank you very much. Oh, look,
thank you.
There's my thunderstorm alert.
Better get to your basement.
Well, he'll get flooded if he goes there.
There is no basement.
Oops. Oops.
All right, everyone. Thanks a lot. Take
Thanks,
care.
everybody. This is great.
Thanks, everyone.
Thanks.